Hello everyone, welcome back. I don't know if you remember, but in the first video I mentioned that when we measure the angle, we measure in in terms of two different units, right? In terms of degree, and the second one in terms of radian. And actually, I give you a relation between degree and radian, but we never learned how to convert. I believe I did one example, but today we're gonna go back to the radian measure one more time, and we're gonna go to the definition of what does it mean by 1 radian, and we're going to be discussing the application of the when the problem is in terms of radian measure. Okay, so let's get started. So we're going to jump to section chapter 6 is section 6.1. Okay. Section 6.1. And put over here radian measure. Okay, so in the first part, let's talk about the definition of radian, and the second part we're going to talk about the application. Okay, we're going to talk about the arc length and the sector area, all of that. So what does it mean by radian? Radian is the unit to measure angle, definitely. But what does it mean by 1 radian? Let's say I have a circle. And I have a center angle like this. And this central angle over here intercept this arc. I'm going to call over here the arc AB. And over here angle O. This over here angle alpha. And you see over here the angle over here intercept the arc AB. So what is the measure of the angle alpha over here? I didn't say anything about is in terms of the degree of radian, right? But let's say that the length let's given that the length of the arc AB is the same as the length of the radius. So what if the length of the arc AB is the same as the radius, the length of the radius? Then this angle, alpha here, this angle alpha over here will be measured by 1 radian. So it doesn't matter how long the arc length, how big the radius. If the length of the arc and the length of the radius equal to each other, then that angle, the central angle, could be 1 radian. It will be 1 radian. And how's the 1 radian? So what does 1 radian means in terms of degree? In order to know that, you have to use the relation. We already talked about that in the first video. And what is the relation? The relation is that if we have pi radian, then it's equal to 180 degrees. So 1 radian and how many degrees? We're going to go ahead and set up the ratio. So we have pi radian over 1 radian equal 180 over x. Then x will be 180 times 1 divided by pi. So pi in this case will be 3.14. So you can take 180 divided by 3.14, which is give you about 57.29596. Okay, radian. Oh, degree. I'm sorry. Degree. So 296. So 1 radian is 57.296 degree. So from here you see that we can go ahead and convert every radian measure into degree measure, and we can convert every degree measure into radian measure easily, right? For example, what if I want to convert 45 degree 45 degree to radian. Okay, if you go ahead and set up the same thing like this, the same proportion as I did over here, then we're gonna have what? We're gonna have pi radian is 180 and 45 degree over here will be how many radian. So we're gonna find x over here, so you're gonna have pi over x equal 180 over 45, and x will be pi times 45 divided by 180. So we're gonna go and simplify that. Clarify 180 will be pi over 4 radian. So 45 degree is pi over 4 radian. If you apply the same logic over here, so we're gonna end up with like 30 degree will be pi over 6 radian. 60 degree will be pi over 3 radian. Okay, and so on and so on. Now, what if the number is not nice? What if the number is not nice? Let's say I have the numbers is I want to convert radian. Let's say I convert is 5 pi over 8 radian to degree. Okay, let's see how many degree. Okay, very easy. Same thing too. We're gonna set up relation. So we have pi radian, okay, equal to 180 degree, and 5 pi over 8 radian will be how many degree? So we do cross multiply. So we have x degree will be 5 pi over 8 times 180 and divide by pi. So we're gonna end up with pi cancel out, so we're gonna end up with pi 5 times 180 divided by 8. So we have 112.5 degree. You see that? Very easy. So convert between radian and degree is super easy, guys. Okay. Now you can go ahead and express that on the unit circle too. So 30 degree, 60 degree. Well, actually, I'm gonna do that in the next section, because actually that's why I say I don't like how they organize this book. They should introduce the unit circle right away at the beginning, but that's okay. We're gonna wait until section 1 to express on the unit circle with the degree measure and radian measure. Now, on the second part of our video, we talk about the application in radian measure and degree measure. So one of the application is we use that relation to calculate the arc length of the circle. Okay. Application. To calculate the arc length. So the first application is to calculate the arc length. What arc length, we can use the proportion to calculate it in terms of degree. But what I have will be, because we already learned radian, so we can use this formula here to calculate arc length in terms of radian. So the arc length will be S equal to theta R. So S is the arc length and R is the radius. Okay, the radius, and then theta is the angle intercept the R. Okay, theta is the angle intercept the R. So if you draw the picture, we're gonna have something like this. Okay, so let's say I want to find the arc length right here. I want to find this arc length right here. I'm gonna call this arc length. So this is S over here, and I have an angle theta over here. Okay, and I have the radius over here, so I can find it given theta in radian. So theta must be in radian. Okay, so theta over here must be in radian. So if the question gives you in degree and we want to use this formula, you have to convert it into radian in order to use this formula. Otherwise, you cannot use this formula. And the arc length and the radius have the same unit, just the length unit. It could be meter, or in centimeter, and so on, and all of that. Okay. Let's do one of the problem here. I think I'm going to give you the formula, next formula before we do example. And the second application is to calculate the sector area. So I have a circle too. Okay, and I want to find the area of the wedge of the pizza. So I want to find this area right here. And I know the angle theta. Okay. So the formula will be A equal to 1 over 2 r squared theta, or 1 over 2 theta r squared. So as long as you see that, as long as you know the radius, you know the theta in terms of, again, the theta must be in radian. Then you can find the area. You can find the area, how big is the piece of the pizza right over here. Okay. Okay, and let's see, we can find some example for you. Some example is really interesting thing, you know. Let me see, I can find something for you. Okay, let's take a look at this example over here. So how we're gonna do this one? So I have a rope. It's been around a drum with radius. So this is a radius. This angle. How much rope will be? I don't know how you pronounce it. Wood around the drum if the drum is rotated through the angle 39.72. So this over here is it roll from here. Okay, it's rotate from here to this position. So here to here to this position. So basically they ask you to find the arc length right here. So so I'm gonna put in so here from here to here. So how much is go from here to here? So basically they ask you to find the arc length right here. Okay, so very easy. So in order to find arc length, we know this is the degree, so we need to convert it to radian. So we know it's pi radian. Pi radian is 180 degree. So we have 39.72. 39.72 degree. Okay, so how many radian here? So we're gonna go ahead and find x. So we're gonna take pi times 39.72, and you divide it by 180. Okay, let's put into the calculator. You can leave pi if you want to. So we have 39.72, and you divide by 180. So you have about if you go ahead and multiply by 3.14 the pi, and you have about 0.69.3, 0.693. So it's about 0.7. So 1.7 radian for that. Okay, now we're gonna go ahead and find the length. How much rope in minute? How big is the length? The arc length right here. So as AB arc length will be S equal theta R. So it will be 0.7 times R is R is 0.8. 0.725. Okay, time 0.875 give you about 0.6485, so 0.05. And don't forget the unit will be in feet. Okay, See, very easy. Wow, look like I still have a lot of space over here. I already put the next example in the next page already, right over here. So I guess I don't know that space have enough room to do that. I think I'm gonna go ahead and change to this example here because I'm afraid that this probably doesn't have enough space. So I just need to move it down a little bit. You just need to move it down a little bit here. How am I gonna move it down? I know that this one I can do like this. Okay, and I move it down like this. And I don't, oh, here you go. This one like this. And I just delete this. I put a view here. Okay. Alright, how about this example? Okay, so you have two gears. It's just so that the smaller gear ride a larger one.